Every second of your life moves in one direction, forward. But what if that's only how humans experience reality? What if somewhere in the universe, time isn't moving toward the future at all? What if another reality exists where tomorrow comes before yesterday? It sounds impossible, yet modern physics suggests the truth may be stranger than science fiction. Tonight, we're exploring one of the greatest mysteries ever asked. Can time flow in two directions? What if everything you've ever believed about time is wrong? Right now, as you're watching this video, time feels perfectly normal. Every second moves forward. Yesterday is gone, and tomorrow hasn't happened yet. We grow older, not younger. A broken glass never rebuilds itself. Smoke never returns to a candle. Every memory points toward the past, never the future. It feels so obvious that we rarely stop to question it. But here's something that might completely change the way you see reality. According to modern physics, the laws that govern our universe may not actually care which direction time moves. That sounds impossible. Because if time could move backward, wouldn't everything happen in reverse? Would people become younger? Would rain rise back into the clouds? Would history erase itself? Surprisingly, that's not what physicists mean. In fact, some of the deepest equations ever discovered work almost perfectly, whether time moves forward or backward. So why do we experience only one direction? That question has puzzled scientists for more than a century. And to understand it, we have to begin with one man whose ideas completely transformed reality: Albert Einstein. Before Einstein, scientists believed time was universal. Imagine a giant invisible clock hanging above the universe, ticking at exactly the same speed for everyone, everywhere. Whether you were standing on Earth, sailing across the ocean, or floating somewhere among the stars, time was thought to be identical. Then, in 1905, everything changed. Einstein proposed something so revolutionary that many people refused to believe it. Time is not fixed. It stretches. It slows down. And under the right conditions, it can pass at completely different speeds for different people. Imagine two identical twins. One remains safely on Earth. The other boards a spacecraft capable of traveling close to the speed of light. After what feels like only a few years aboard the spacecraft, the astronaut returns home expecting life to be almost unchanged. But Earth tells a different story. Decades have passed. Friends have grown old. Entire generations have come and gone while the traveler aged only a few years. This isn't science fiction. It's one of the most astonishing predictions of Einstein's theory of relativity, and countless experiments have confirmed that time truly does slow down under extreme conditions. Even something as ordinary as your smartphone depends on this idea every single day. GPS satellites orbiting Earth experience time differently because they're moving rapidly and are farther from Earth's gravity. Their clocks drift by tiny fractions of a second. Those tiny errors are corrected constantly. Without those corrections, your navigation could become inaccurate. That means every time you open a map on your phone, you're using technology that quietly depends on Einstein's understanding of time. But if time can slow down, a much stranger question begins to emerge. What actually decides which direction time flows? Why do we remember yesterday instead of tomorrow? Why does every experience move toward the future instead of the past? The answer isn't as obvious as it seems. Because when physicists write the mathematical equations describing motion, gravity, electromagnetism, and even many parts of quantum mechanics, something unexpected appears. The equations often work exactly the same if time is reversed. Mathematically, the universe doesn't always seem to prefer one direction over the other. And that's where one of the greatest mysteries in modern science truly begins. If the laws of physics don't seem to care which direction time moves, then why does our everyday world clearly move in only one direction? Why does a dropped glass always shatter instead of rebuilding itself? Why do we remember the past but never the future? The answer may lie in one of the most important concepts in modern physics: entropy. Entropy is often described as the measure of disorder in a system. Imagine opening a brand new deck of cards. Every card is perfectly arranged. Shuffle the deck 100 times and the order disappears. Nature behaves in a similar way. Things naturally move from order toward disorder. Ice melts into water. Hot coffee cools down. Buildings slowly decay. Stars burn through their fuel. The universe constantly evolves toward higher entropy. This increase in entropy creates what scientists call the arrow of time. It's the reason why yesterday feels different from tomorrow. The laws of physics may allow time-reversible equations, but the growth of entropy gives our universe a preferred direction. It's like watching a movie. You instantly know whether it's playing forward or backward, not because gravity changes, but because broken objects don't magically repair themselves. Smoke doesn't return to a candle, and spilled water doesn't jump back into a glass. Entropy gives time its direction, but here's where things become even stranger. Some physicists believe this arrow of time might not be universal. Imagine another universe born alongside ours during the Big Bang. In that universe, entropy could increase in the opposite direction. To us, time there would appear to run backward. But for anyone living inside that universe, everything would feel completely normal. They would remember what they call the past, grow older according to their own timeline, and experience life exactly as we do. The only difference would be the direction in which entropy increases. This idea isn't proven. It's a theoretical possibility proposed by some physicists attempting to explain why time has a direction at all. If true, it would mean the universe is even stranger than Einstein imagined. Instead of one universal arrow of time, reality could contain multiple arrows pointing in different directions. And if that's possible, one question becomes impossible to ignore. Could there be a place where two opposite directions of time actually meet? Surprisingly, modern physics offers a few fascinating possibilities. One of them is the black hole. A black hole is a region of space where gravity becomes so powerful that nothing, not even light, can escape once it crosses the event horizon. Near a black hole, time behaves in extraordinary ways. To an astronaut falling toward the event horizon, everything would seem perfectly normal. But to someone watching from far away, the astronaut would appear to move slower and slower, almost frozen in time. This strange effect, known as gravitational time dilation, has been confirmed by Einstein's theory and supported by real observations. Black holes don't reverse time, but they prove something remarkable. Time is flexible. It can stretch, slow down, and behave differently depending on gravity. Then comes an even stranger idea: wormholes. Imagine folding a sheet of paper until two distant points touch. Instead of traveling across the entire page, you simply pass through the shortcut. A wormhole is a theoretical tunnel connecting two distant regions of space and possibly different moments in time. If such a tunnel could exist and remain stable, it might allow travel across unimaginable distances, or even different points in time. But there's a problem. No stable, traversable wormhole has ever been discovered. According to current theories, keeping one open may require exotic forms of matter with properties that have never been observed. So for now, wormholes remain mathematical possibilities rather than scientific reality. Quantum physics makes the mystery even deeper. At the smallest scales of the universe, particles behave in ways that seem to defy common sense. Some quantum processes appear almost perfectly symmetrical in time. In many equations, replacing forward time with backward time changes almost nothing. That doesn't mean particles are literally traveling into the past, but it suggests that the fundamental laws of nature may be more balanced than our everyday experience. Even today, physicists continue debating one extraordinary question. Is the direction of time a basic law of nature, or is it simply an emergent property created by entropy after the Big Bang? If the second idea is true, then somewhere beyond our observable universe, another reality could experience time in a completely different direction. We don't know if such a universe exists. There is no experimental evidence proving it. But the mathematics leaves the door open. And sometimes, in science, leaving the door open is the beginning of the greatest discoveries. But after more than 100 years of research, the biggest question still remains unanswered. Can time truly flow in two directions? The honest answer is that nobody knows. Science has revealed that time is not as simple as it appears. Einstein proved that time can slow down. Modern experiments confirm that gravity changes the rate at which time passes. Quantum physics suggests that the deepest laws of nature may not always distinguish between past and future. Yet none of these discoveries prove that humans can reverse time or travel into the past. They simply show that reality is far stranger than our everyday experience. Throughout history, humanity has repeatedly discovered that the impossible sometimes becomes possible. There was a time when flying across the sky seemed like fantasy. Landing on the moon sounded impossible. Carrying a supercomputer in your pocket would have been unbelievable just a few decades ago. Every generation has watched science transform dreams into reality. Could understanding time be the next great revolution? Perhaps one day scientists will discover a new theory that unites Einstein's relativity with quantum physics and finally explains why time has a direction. Or perhaps the universe has hidden rules that forever prevent time from flowing backward. Whatever the truth may be, one thing is certain. Time is not just the ticking of a clock. It is woven into the fabric of reality itself. Every star that shines, every galaxy that drifts through space, every black hole that bends gravity, and every second of your life is connected to one of the greatest mysteries ever known. Maybe the universe has only one arrow of time. Maybe countless universes exist where time flows differently. Or maybe the answer is something no human has imagined yet. Until science uncovers that answer, the mystery remains open. And perhaps that's what makes it so fascinating. The universe doesn't owe us simple answers. It rewards those who keep asking impossible questions. So the next time you look at a clock, remember that it may be measuring far more than seconds. It may be measuring one of the deepest mysteries in existence. If you enjoyed this journey into the mysteries of space, physics, black holes, and the unknown, subscribe to 0 Hours for more cinematic documentaries that explore the biggest questions in science. Because the next mystery might completely change the way you see reality. Maybe time has only one direction. Maybe another universe experiences it differently. Or maybe the greatest discovery in human history is still waiting to be made. Until that day comes, one thing is certain. The universe is far stranger than we ever imagined. If you enjoyed this documentary, subscribe to 0 Hours for more mind-bending mysteries about space, physics, black holes, and the unknown.